All right. Good morning. Good morning. You're welcome to today's class on pharmaceutical calculations, revision, National Pre-Certification Examination 2023 revision, NPCE, in pharmaceutical calculation. Today we are going to answer solve a calculation under the topic. The topic we'll start with is density, specific gravity, and specific volume. Density, specific gravity, and the specific volume. All right. Put down this question. Put down this question. Drug X has a specific volume of 0.1 ml per 30 units. Or simply say drug S, okay, yes, that is what it is. Drug X has a specific volume of 0.1 ml per 30 units and is required as an injection containing 6 units in 1 ml, and is required as an injection containing 6 units in 1 ml. Full stop. Drug X is available as a powder suitable for reconstitution into an injection. Drug X is available as a powder suitable for reconstitution into an injection in a vial containing 90 units. Full stop. What is the volume of diluent? What is the volume of diluent that should be added to the powder to produce the injection solution? What is the volume of the diluent that should be added to the powder to produce the injection solution? I'll give you 3 minutes to solve this question and get back to me. 3 minutes. 3 minutes. All right. Let's see what Chinaza, seems Chinaza has finished. Let's see what she has for us. Maka is there.
He said that the drug has specific gravity of 0.1
Specific volume, not gravity.
per 30
Units, okay.
And it is required as an injection containing 6 units.
Okay.
6 units. And they are now asking us what is the volume of diluent that should be added.
6 units per what?
Okay, in 1 minute.
In 1 minute, okay.
They're now asking us what is the volume of diluent that should be added to the powder to produce the solution. That is this 6 units in 1 minute.
Okay.
So can I say that if 0.1 ml is in 30 units, then how many, like what is the volume in the 6 units, which is the injection we asked to prepare? Let's multiply it to be 6 units times 0.1 ml, 30 units. And so it's 6 units. 0.1 divided by 5 is
0.02 mil is what?
Is the volume
Of the what?
of the diluent
That we've added to produce 6 units. Sit down. Any other person? Preacher, come and try. Come and try. That thing you have been doing since, come and do it on the board. Let's see. Don't give up. You don't understand the question. Okay. Now, let me start from the scratch. Have you noticed, or did you notice during your IT? Did you notice at all? Thank God all of you did IT. Did you notice some drug like azithromycin? Some drug like azithromycin. Some drug like, let me say, azithromycin powder for suspension, for oral suspension, right? Have you noticed that this azithromycin specifically? Have you noticed that they will tell you that in this powder, just pour maybe 9 ml of water. They will specific to the amount of water you pour for you to get 200 milligram per 5 ml. Have you noticed that? Have you noticed that? They will specific on the amount of liquid water to be poured. But some oral powder for oral suspension may just go on the bottle and put a line. They will tell you to pour water in the powder, mix it well, dilute it, then make it up to that level. But azithromycin will tell you specifically pour 9 ml of water. You know, we used to tell you make it to the final volume, because if you pour it to that volume, it may offshoot. Why does it offshoot? Why does it offshoot? Remember, if you remember when we did this thing, they'll tell you, okay, add small amount of water in that powder, oral powder for oral suspension. Add small amount of water, shake it well, dissolve it, then keep pouring water until you get to the mark. Then I also told you that if you pour water in the bottle until you get to the mark, and if you mix it, the final suspension will do what? We go above, we offshoot that mark. Why does it offshoot the mark? It's because of specific volume. These powders have what you call specific volume. This volume is the volume of water that is displaced by this powder. So using specific volume of azithromycin, they calculated that what will give you the actual concentration, 200 milligram per 5 ml, is say 9 ml of solvent. That's what the calculation they did before they now conclude. Now, using this question as an example now, the drug S, specific volume of drug S is this, 0.1 ml per 30 units. What it means is that 30 units of drug S will displace 0.1 ml of what? Water. That's the meaning. And you must put, except if the specific volume is negligible. You can neglect it, but once it's not, you must put it. But if you don't put it, you will produce a dilute solution. Like now, in a powder for oral suspension, that they put a mark here, and you pour water get to this place, and you shake it, the final volume got up to this level. This thing will be diluted. True of us, it will be more diluted than the original intended strength, because the concentration, the amount here is constant, it's not changing, but the volume of the entire suspension has increased, so it will decrease the concentration. This amount is constant divided by the entire volume of the suspension. You keep it the same constant amount divided by the higher volume of the suspension. The concentration, the strength will do what? Decrease, to avoid mixing what we give you a lower strength. You put the displacement volume of that powder into consideration. That's what zero mass calculated. That's what Pfizer calculated the zero mass. Before they can tell you, they could tell us, okay, use so mil of water. Once you add it in this thing, you get the strength. That is the importance of this what? Specific what? Volume. That's the relevance of the specific volume. Now, having known that the specific volume of this drug S is 30 units, 0.1 ml per 30 minutes. What it means that 30 units of that, 30 units of the drug S will displace 0.1 ml of what? Water. So having that at the back of our mind, let's go to the question. The question says, read the question again. It says, drug S has a specific volume of 0.1 ml per 30 units and is required as an injection containing 6 units. So the strength of the injection they want to reconstitute is 6 units per what? 1 ml. 6 units per 1 ml is the strength of the injection we want to do what? This is strength we want to get. So now the last part of the question says, drug S is available as a suitable powder suitable for reconstitution into an injection in a vial containing 90 what? So the vial contains 90, the powder, 90 unit powder of the what? Drug S. And you now ask, what is the volume of diluents that should be added to the powder to produce the injection solution? It's not starting with what the instance I gave you about Pfizer now. They're asking you the volume of the diluent you should add inside. That's what you want to do what? Determine. Now, having known that the powder in the injection vial is 90 units, and you want to produce a strength of 6 units per 1 ml. So we want to know the entire volume of the entire volume of the final solution in the injection vial you get. How do you get it? Since 6 units is in 1 what? Ml. 90 units should be in what? X. Is it clear? Since we know that the strength you are looking for is 6 units in 1 ml, but we say that the powder is 90 units. So we want to get the entire volume of this solution you will form. So the entire volume is 90 units. It should be what? X. If we have 6 units in 1 ml, 90 units of the powder drug S should be in what ml? 90, you cross multiply, right? 90 times 1, X is now equal to what? 90 units times what? 1 ml over what? 6 what? Units. Unit cancel unit. We are left with 90 times 1 ml. So, 6 will divide 90. 6 divided 90 is what? 15. So we are left with 15 times 1 ml, which is what? 15 ml. Now, the volume of the entire injection solution in the vial should be what? 15 ml. How do we now know the volume of the what? Diluent to be added? Putting into consideration the specific volume of that what? Diluent. If you mistakenly carry 15 ml, silence your phone, please. Silence your phone. We are in class, please. Silence your phone, please. If you mistakenly carry 15 ml of the diluent and pour a 90 unit of the powder, you will get a dilute solution that will be less, that have less strength than this. You may have something that maybe around 5 point something unit per 1 ml. So what you will do is to use this specific volume of the what? Specific volume of the powder to set a proportion with this thing. And know what it will look like. So if the powder, if 30 units of the powder displaces 0.1 ml of what? Water or diluent, what will 90 units of that powder displace? Remember, the powder is already inside the what? 90 units is what is inside the vial. If you pour water, the diluents, be it water, whatever, if you pour it inside that vial, that 90 unit will displace some volume of the what? Diluent. So if 30 unit displaces 0.1 mil of diluent, 90 unit inside a vial, how many mil will it do what? Displace. So you know how it's 90 units will displace what? X. We don't know it. So X is what? 90 units times what? 0.1 what? Mil. All over what? 30 what? Units. Units will cancel units. 30 divided 90 is what? 3. 3 times 0.1 is what? 0.3 what? Mil. So what it implies is that the 90 unit in the vial will displace 0.3 units of the mil of the what? Diluent. So to put it into consideration, subtract this 0.3 mil from 15 mil to know the volume of diluent you should add. So if you subtract this 0.3 mil from 15, this 15 mil is the entire volume of the what? Solution. But 0.3 mil is the volume that is displaced by the what? Powder in the vial. So to know the volume of the diluent to be added, you subtract 15 to get this concentration, this strength. You subtract 15 mil, 0.3 mil from 15 mil. So volume of diluent to be added is now what? 15 mil minus what? 0.3 mil. The answer is what? 14.7 mil. So if you truly want to target this strength, what you do is just simply add 14.7 mil of the what? Diluent. Everything will give you what? 15 mil. Have you seen how Pfizer did that calculation? That's what they can comfortably tell you, to add 9 mil, and you get it. Now see what happens if you mistakenly. Okay, now let's check the concentration. Let's see whether we can get this strength. 90 mil, 90 unit of over the entire volume of this solution is what? 15 mil. Divide it, see whether you get this strength. But if you mistakenly add 15 mil, see what will happen. If you add 15 mil in the powder, this is where the powder is here. If you add 15 mil of water, of the diluent, it will offshoot above 15 mil by 0.3. So the volume of the entire system will become what? 15.3 mil. And if you check the strength, 90 units over what? It will be lower than this strength. So you have diluted the what? And you know this may be antibiotic or so. As you diluted it now, it will give you the required strength that will take care of the what? Of the what? Microorganism. And resistance may do what? Ensue. Is it clear? If you have any question, ask. So what you add is what? 14.7 mil of the what? Diluent. If you have any question, please feel free to ask. If you have any question, feel free to ask. All right, I don't know if you have any question. In the absence of any question, I want us to take a question from the dilution. Dilutions. Now let's look at dilution. Let's look at dilution. There's an area of we are familiar with normal dilution, we know, right? There's an area I want to go. I want to go to the area of mixing concentrations, mixing to alligation. I want to go to the area of alligation. Okay, that's where I want to go. I want to go to the area of alligation. Then let me look for a question. Let me use a question to describe it. Okay, I made mention of mixing concentrations. In dilution, we are familiar with normal dilution, dilutes and dilution formula. I don't want to go into that. C1V1 is equal to C2V2. That one is simple. Where the issue lies is when you now want to mix concentrations. Normal dilution is that you put water or any other diluent, right? Then you now determine the final concentration. Yes, or maybe you know the final concentration. Now you want to determine the volume of the diluent to be added to get a specific concentration. But this type of thing, in this situation now, we are talking about what? Mixing two different concentrations, two different strengths. Now with that, you need to determine the final strength of what you form. Or sometimes you may know the final strength of what you are looking for, but you don't know the proportion in which the two solutions we are mixed to get that final what? Strength. Now this is what we call what? Alligation. We have the one we call in alligation, I think Alligation Medial or something, an alligation alternate. An alternate in media, you don't know the final concentration, but you know the initial concentration of the two solutions you want to use. But in alternate, you know the final concentration, but the concentration, the concentration, that's why you don't even know the exact concentration of the two solutions you mix. Sometimes you may know the concentration, but you may not know the volume proportion in which they are what? Combined. So this is what alligation is all about. So with this simple little explanation, I want to pick one question from each of them to explain that. I don't know if they go to that extent, but is in your what? Alligation is in your what? Curriculum. That's why I'm discussing it. You are familiar with normal dilution. So I pick the things I know that you may have one or two issues. And then after that, if there's time, we still, this is coming off from first, right? Good. Right? Good. Now, put down this question. Let me use this question to explain what I just to bring home what I just said now. What is the final concentration? Or simply, yes, that's what it is, but they wrote, what is the final percentage volume in volume? What is the final percentage volume in volume of a solution? If 200 ml or 40% of solution is added to 300 ml of 70% volume in volume what? Solution. Let me come again. What is the final percentage volume in volume of a solution if 200 ml or 40% volume in volume solution is added to 300 ml of 70% volume in volume solution? What is the final percent volume in volume of a solution if 200 ml or 40% volume in volume solution is added to 300 ml of 70% volume in volume solution? If you look at this question, we have solution A and solution what? B, right? And solution A, we have solution A and solution what? B. Are we together? Are we sure? Please look up. We have solution A. This is solution A, right? It's the same solution, but with different what? Strength, right? We have solution A. We have solution what? A plus solution what? B. Solution A plus what? Solution B to form solution what? C. They contain the same thing, it's the same solution, but different strength and volume. Now, from the question, solution A is what? 200 ml of 40 what? So VA is what? 200 what? Ml. CA is what? 40% what? VB is what? 300 ml. CB is what? 70% what? VC is what? CC is what? We don't know. So we use alligation what here? Alligation what? This is in the course material I gave you now. In your Okay. Okay, you show it an assignment. But it's in textbook. I mean, them. Look for the name there in that textbook. It's there. Look for the name in the textbook. There are two allegations. We have Alligation Medial. Look for it there by yourself. Open it by yourself and look for it. Why I'm so particular about this allegation is that it's another part of dilution that one need to be what? Very careful with. It's not your regular dilution where you just say C1 V1 is equal to C2 V2. There are some things you need to check out from here. So I told you that alligation is just process of mixing what different concentrations to get a particular word concentration. So you have sometimes you have two of them. You have alligation medial and an alligation what? Alternate. Now I told you that in medial, as you can see here, you don't know the final concentration. You don't even know the final what volume, but you know the volume and concentration of the what you are mixing. Am I communicating? Now this one is simple. Just follow the normal dilution principles and get this thing. Now remember, concentration is I will say ratio, but it's not a ratio as per ratio in terms of maybe what ratio actually is. Remember, I told that ratio, as in ratio, you have to do what? The unit of the numerator and the denominator should be what? The sentence, so they can cancel out. Yeah, but I can express it as a ratio term in a way, but not ratio as per ratio, because concentration has to do with what? The amount of the what? Active ingredient, right? Divided by the amount of the what? The entire what? Product. True or false? That's concentration. Now, be careful about that. If you're not careful, you just simply go and add 40% weight per volume plus 70% weight per volume. What will you get? 110 weight per volume, which is wrong. So see the implication. If you just add 40% weight per volume and add 7% weight per volume, you get 110. What they are telling us there is that their concentration, adding two of them, the concentration will be what? Higher, which is wrong. Now look at this thing. Now let me just use your common sense now to answer this question before I solve it. Let me know whether you have a background. This thing. Look at this thing now. If you add these two concentration, can you let me see? Can you describe? You may not be able to say the exact concentration you get because we have not done the calculation. But can you describe the concentration of the whatever you are going to, this C, with respect to A and B. Just you can't be specific because you have not answered, you have not solved the question. But can you describe the concentration of C with respect to A and B? Concentration of A and B. If you mix this in now, just use your normal mixing of two things together, two liquids. No, just no figure. Just tell me. Just describe how it will look like with respect to concentration of B and A. Which and which will be? Do you think it better will be bigger, higher? Do you think it will be higher or lower? That's what I want to just give me an idea. What do you think?
The concentration of C will be
higher than what?
Than A.
It should also be higher than B. I need a critical thinker here. Do you think concentration of C will be higher than A and B? A and B are mixed together. A with 70% weight per volume, almost twice A. Don't you think that if you mix them together, it will drag? Concentration of A will drag concentration of B lower. C should be between A and B. The final concentration, which is C, should be higher than A, and it should be lower than what? B. It should fall within this, between it should lie between 40 and what? 70. This type of thing can form a question. I think I've seen a question like that even in WAEC, even in JAM chemistry. I've seen a question like this even in JAM chemistry. So it can form a question. You may be waiting for them to give you one big calculation. You may see a question like this. Asking which and which. If you mix A and B, what do you think should be the concentration of C? You start seeing less than 40% weight per volume, more than 70% weight per volume. You see a question like this. I've seen JAM chemistry question like this, like just like this, exactly here now. So it should. So let's do the calculation. Come on, okay? Let's check and know that is what true. Even though the volume also has to be there too. The volume should be there too. But let just if you use this volume and this volume, let's see what we get. Are we together? Let's see what we get. Now let's go. Let's see whether what I said now is true or not. This is just an assumption. I'm just looking at the concentration and fix something that I think. But it's when we do the calculation, we know exactly what it is. Are we together? Now, look at this thing. So, remember that concentration is what? Is what? Amount over what? Volume, right? This is what? Concentration. Amount over what? Volume. Now, here, let's change this 40% to what? Let's change this percentage to amount to what? Concentration. Are we together? Let's change this. Let's move it from percentage concentration to what? Amount to what? Concentration. Now here we give us, here we have, if this means what? 40. Remember this is volume in volume, right? 40 ml in what? 100 ml. True of us? True of us? Good. This is 40 ml in what? 100 ml. Amount in ml over what? Volume. But the volume is what? 200 ml. So it becomes what? Multiply everywhere by 2 to true of us. Because here I have 200 and car getting 100. So double of this is in car, right? So the up should also be what? Doubled, right? So if you want to get the exact amount of this in 200 ml, it should be what? 80 ml over what? Are they equivalent fractions? Are there equivalent fractions? Remember, we did equivalent fraction. Just simply divide by 2, and you get this in. So they are what? Equivalent fraction. So here is what here can actually be not called we can leave this as A as 80 mil over what? Do you agree with me? Do you agree with me? Good. Let's do the same thing we did here in what? B. Now, remember that B is 70%. So this means what? 70 mil in what? 100 mil. But the volume is what? 300 mil. 300 divided by 100 is what? 3. So you multiply everything by what? 3. So this will give you what? 70 mil times 3 is what? 210 mil over what? 300 mil. 210 mil over what? 300 mil. So I can comfortably leave this place as what? 210 mil over what? 300 mil. True of us? I can leave this like this. So I have moved this whole thing now. Put it in what? Amount concentration. So this thing actually, this A contains 80 ml of the drug in 200 ml of the entire what? Drug product. True of us? While this contains 210 ml of the active ingredient over in 300 ml of the entire what? Drug what? Product. We are mixing the two. If you want to mix the two, this is not your normal fraction. Remember. So you simply do what? Add the active ingredient and active ingredients. Write out the answer. Add the what? The entire volume of the mix of the solution, this and this. Then bring it down to percentage concentration, and you get the concentration of the what? Of the what? Phi of the C, and also the volume of C. From here, what do you think should be the volume of C? Volume of C should be what? From here now. A is 80 mil in 200, 80 mil in 200 mil. B is 210 mil in 300 mil. So C should be what? Volume of C should be what? 500 mil. Good. Volume of C should be what? 500 mil. So let's determine this concentration now. This 80 mil plus 210 is what? 2 what? 90 mil in what? 500 what? Mil. So we have determined the volume of C, right? To be what? To be what? Even here, self. You can even simply add it, but you cannot do it like for what? Concentration like that. You must break it down. Come out the exact amount of the active ingredient inside it before you can continue your what? Calculation. So we have gotten that volume of C is 500 mil. Then we have inside C. We have 290 mil of active ingredients in what? 500 mil. So let's find the percentage concentration of this. It's simple, right? Simply divide. Remember, for those that are doing calculation in your OBJ, remember you don't waste it. Just simply divide this by what? 5, right? By what? Is it 5? Yes, 5, right? Simple. Answer about long here. True of us. If this is a fine in what? 500 mil. How many will be in 100 mil? That will give you the percentage. So divide everything here by what? 5. You have what? This is what? The numerator is what? The numerator is what? 100 mil. 290 divided by 5 is what? 290 divided by 5 is what? 58 what? Mil. So the percentage is what? what's the percentage concentration here now? 58 what? Percent what? This is concentration of C. And this is the volume of C. Now check, where does it lie? It lies between 40 and what? 70. That's the power of what? Mixing concentration. As you mix A and B, it will drag, A will drag the concentration of B down. Where O will come up, they will meet at what? 58% weight. So the volume of the final solution formed when you mix two of them is 58% volume per volume. That's the concentration of C. While the volume is what? 500 what? Ml. This is alligation what? Medial. Alligation what? Medial. You can also find alligation medial in solid dosage form, not only in what? Liquid what? Dosage form. We call this pattern alligation medial. It's straightforward. The most important thing is for you to always remember that you don't add this concentration like that, because it's expressed as a fraction or as a ratio. So pull it back to what? Amount concentration. Then add the what? Active ingredient, and add the what? The entire amount of the what? The products, drug products. Then divide through, convert it to percentage. You have your what? The percentage concentration of the final what? Solution. But for the volume, just add the volume and get your what? Answer. So the concentration of C is 58% volume in volume. Any question on this? Any question on this? Remember, have you now see? Did your C1V1 save you here? Did your C1V1 save you here? So please, every dilution is not C1V1, C2V2. That one is when you're using a diluent that doesn't have any amount of active ingredient. You are diluting it to produce a new. You are diluting it. But this one, if you have if what you are adding there also has what contains that active ingredient, be careful. Use what? Alligation what? Medial. Because you are mixing concentration. Because on taste we call it mixing concentrations. So now I don't want to go deep and start proving the formula for alligation. We don't have time for it. I want to give you a formula for alligation alternates. Then we'll solve a question there. I don't want to start proving the formula. No time for that one now. Now, let me give you a formula for alligation alternates. Then with that, we can use it to solve a question. Then we'll take it off from there. Now, for alligation alternates, put down this formula. For alligation alternate, put down this formula. Are we good? What I clear at Chokanabia class? You put a live any. Or don't need to be able to. How can be ego? All right, let's continue. Now we have V1 over V2. V1 over V2 is equal to, or let us change that one to A. Sorry, that one make it because we said it with A already. Okay, make it A. It's okay. Make VA over VB. VA over VB. So if you are studying it, you understand what A and B represent. So you wouldn't confuse that. So VA over VB is equal to bracket open. CC as in like this. C subscript C minus C subscript B. Then you close the bracket, or you can leave it only you mean, but you just for you to know that there is one term. Are we together? Then all over CA minus CC, CA minus something like this. VA VB is equal to CC C what over what? C what minus what? C what? This is formula for what? Alligation alternates. This is formula for what? Alligation alternates. I will give us a question now, then we use it to explain this formula. Remember I told you something that sometimes here now, in this case now, you don't know the final concentration, right? Sometimes you may know the final concentration, but you will not know how this proportion in which they were combined to get this final what? Concentration. You have to find it. This is the formula you can use to find it. Let's solve this. Let's look at this question. After this, we move to another question, another topic, so we can cover as many as we can before you are. Because after you are this all of you disappear. You hibernate. After your mock exam now, you hibernate. 3 of us. Now, let's look at this question. Okay, look at this question. Look at this question. It says, a suspension used to be provided as 2 strengths. A suspension used to be provided as 2 strengths, comma. Both 100 milligram per 5 ml and 25 milligram per 5 ml solutions. Is the same suspension. I hope you know. Are we together? It's the same suspension. I hope you know. But in 2 different what? Strengths. Are we together? Now let me come again. A suspension used to be provided as 2 strengths, both 100 milligram per 5 ml and 25 milligram per what? 5 ml solution, which could be mixed to produce intermediate doses. Which could be mixed to produce intermediate doses. Full stop. If we want to produce a product that has a strength of 75 milligram per 5 ml, if we want to produce a product that has a strength of 75 milligram per 5 ml, comma, what proportion of the 2 mixtures do we need? What proportions of the 2 mixtures do we need? What proportion of the 2 mixtures do we need? What proportion of the 2 mixtures do we need? Now, let's assume where you are working, you have 2 suspensions, right? Let me bring it home so it doesn't look so what? Abstract. If you have two brands, for example now, even though 2 brands of the same suspension. Now, this volume of this one, they have 2 different strengths. 2 of them have 2 different what? Strength. Let's assume amoxicillin 125 milligram per 5 ml or augmentin 228, anyone. Let me say amoxicillin 125 milligram per 5 ml. They may be the same brand, okay? Now, but you also have another one. Even this is not practical, but I just want to explain something. And you have another brand, or even the same brand, but the same amoxicillin inside it, that has a strength of, let's say, 250 milligram per 5 ml. Now let's assume that there's something you want to get. The volume of one is not enough. The volume of maybe the first one is not enough for you to get what you want to achieve. Am I communicating? Now you will be forced to mix two of them to achieve a particular strength you want to give to the baby. Now, since you have known the strengths of the three of them, the strength you want to achieve, and the strength of the two suspensions you want to do what? Mix. If you know these three strengths, CA, CB, and CC, you can comfortably determine the volume, proportion in which you can combine the two of them to achieve your what? Strength you are looking for. That's what alligation alternate is all about. Provided you know the three concentrations, the first concentration, the two concentrations of what you want to mix, and your target concentration, you can determine using this formula the proportion with which you can combine the two what? This is to get the strength you are what? Looking for. Now let's look at this. Even though this I said now, if you are mixing two different brands of a substance, sometimes I wouldn't advise that because you don't know the excipient two of the companies used. Okay, you don't even know whether this excipient in this one, they will not tell you all the excipient they use. You don't know whether there will be any interaction between excipient this person used and excipient this person used. You don't know anything about it. Not that it may not happen, no, but as somebody in this line, you should be careful about all these things. But you don't know, you don't even know because they didn't disclose to you. You don't know the possibility of interaction. That's why sometimes it's not good to get this brand and mix what, even though people do it and they go scot-free, fine. But sometimes why it's good to avoid that, you don't even know the excipient. Yes, active ingredient is something, but do you know the excipient? Do you know whether there is a possible interaction between excipient in this one and excipient in that one? Do you know all these things? You don't even know. So personally, in practice, that I don't do it. I try to avoid anything that may cause issues. But that is topic for another day. Now let's do what is now described now. Let's solve this question. In this question, you have the same suspension, two different what? Strengths. So we call the first strength solution what? A. We call the first strength solution what? A. Then the second one is what? Solution what? B. If you use alligation medial, now this question, you use alligation what? Alternate. Remember we say have our what here? E. A, right? We have our B and we have our what? C. Now here, do we know the volume of A? We don't know. No volume was given, right? Yes. Concentration of A is what? 100 milligram per what? Volume of B? We don't know. Concentration of B is what? Per what? Volume of C, VC? We don't know. Concentration of C is what? 70 what? 75 what? Milligram per what? 5 mil. Now, these pharmacists or pharmacy technician want to mix these two things to get this concentration for whatever you want to use it for. Let's assume that you have solution A. They will sell the volume. These are the type of questions I don't have time to give questions. Practical oriented questions I enjoy well. And if you know these things, you will become master of this topic. Just get this thing, get solution get a solution. Say the volume will not be known. It will be level A. Second solution, the volume will not be known. It will level, the concentration will be there, level B. C, and see how can you combine these two things to get this concentration, 75 milligram per 5 ml. It's simple. Just apply this formula, you get your answer. If you watch this formula, what you want to get is ratio, proportion, right? VA over what? VB. Simple. So just from this formula, simply say VA over what? VB is equal to what? CC is what? 75 what? Per what? 5 what? Mil. To avoid issue of trying to cancelling numerator, you may want to turn it and make mistake. Move this to what? Percent what? Concentration straight. Are you together? So if you move this percent concentration, it's simple. Simply divide this in, simply multiply everything by what? 20. True of us? Yes. Multiply everything by 20, right? I don't believe you. In 5 mil, this is in 5 mil. How many will be in 100 mil? This means 75 milligram in what? 5 mil. Oh yeah. And if you want to push it in percent, even though this is a milligram, you have to convert this one to what? Gram. See what you simply do. Find it in what? 100 mil. Simple. Multiply numerator and the denominator by what? All those things you are doing, equivalent fraction is because of this thing. What is the equivalent fraction of this thing that will make the denominator 100 mil? What do we use to multiply everything? 20. Multiply this by 20 and this by 20. This one is what? Change it to gram immediately, sharp, no time. 1.51. Let me slow down. This convention says that if you are moving to percentage concentration, it should be gram in what? Mil. Mil is okay, but up the numerator is what? Milligram. So we should move it to what? Gram. So if you multiply this and this by 20, you get what? 1,500 milligram over what? 100 mil, right? But we are not going to pick 1,500 what? Milligram. We move it to gram. It becomes what? 1.5 what? Gram. Aria. Straight to gram. You multiply here by 20. If you multiply 75 milligram by 20, you get what? 1.5 milligram. Change it to gram straight. You have 1.5 gram.
Why are we multiplying by 20?
Okay. This is what? Have you seen what you are winching? You were cool, not 2 years. Not 2 years. But in your exam, you don't need to go and not 2 years. You meant in number 10 at the C exam. Not doing anything. Just try to look for what? Short cut. It's simple. We want to convert this to percentage strength. And this is amount strength. Remember our amount strength, ratio strength, percentage strength. Remember all those ones we did. This is in our amount strength. And if you want to convert percentage strength, it should be in 100 mil. Gram in 100. How many gram in what? 100 mil will give you percentage strength. Now we want to remember our equivalent fraction we did. What is the equivalent fraction of this that will make this 5 mil to be 100 mil? You multiply by what? 20. This one and this one, the equivalent fraction. Are they not? They are. Once you move this to what? Milligram, they become equivalent fraction. True of us. But if you multiply this by 20, you get 1,500 mg. The convention say that if you're talking about weight in volume, the weight should be in what? Gram, not in milligram. That's why we move 1,500 milligram to what? Gram. And got what? 1.5 gram. So the percentage of this is what?
1.5.
Good. 1.5 what? Percent weight per what? Volume. Percent what? Weight per what? So our CA is what? 1.5% what? Weight per volume. Then minus CB. Oh yeah. A mistake. Okay, sorry, that's CC. That's CC, sorry, for the formula CC, sorry. Minus CB. Look at B here. From what we did here, what do you think this should be without even wasting time? Let's just do this sharp, no time. Multiply it. 225 times 20 is what? 0.5. Are you sure? Minus what? Pepe is having an issue with this concentration. No. You are saying milligram. Yes, just move it straight. 0.5% weight in what? Volume. All over what? CA is what? This one is what? Perfect. 2 what? 2% what? Weight in volume. Minus what? CC is what? 1 point what? 5% weight in what? Volume. What's the answer? 1.5 minus 0.5 is what? 1. This minus this is what? 0.5, right? 2 minus 1.5 is what? Someone is lost. James, what is it? Okay, yeah. How you got what? Okay, let's break it down again. From here. Oh yeah, do the same thing we did here. Here is 20, right? 20 times 100 is what? 2,000. 2,000 milligram, right? Over 100 ml. Convert 2,000 milligram to gram. Convert 2,000 milligram to gram. Ochoa calculator. Okay, sorry, I do it at your pace. Oh yeah. Is what? Allow her. Is what? How many milligram make 1 gram? How many milligram make 1 gram? Milligram make 1 gram. So it's 2 gram, right? So here now, that means this statement is saying 2 gram over what? 100 ml. Convert this to percent. Or 2%. Because 2% is 2 gram in 100 ml. So that's why it's what? 2%. So if you subtract 2%, 1.5% from 2%, you will get what? 0.5% weight in what? Volume. This divided by this will give you what? 2 over what? Over what? 1. Remember, we are looking for what? Ratio, right? 2 over what? 1. So the proportion, good. The proportion you want to combine the two of them to produce what you are looking for. The proportion of these two, the ratio with which you combine the two of them is 2 is to what? What it means is that at any point, no matter the volume you want to mix, also if no matter the volume you want to use, all we know is that the volume of A must always be twice the volume of what? B. Is it clear? That's the meaning. So this is remember the question says what proportion, right? Is 2 is to what? 1. So at any instant, no matter the volume you are going to use, the volume of B, volume of A must be twice the volume of what? B, right? Why volume of A should be what of volume of B? Why volume of B should be what of volume of A? Good. That's the meaning. Volume of A must be twice volume of what? B. Why volume of B must be always be half of volume of what? Now, some question may not end at this level. Some question may ask you to determine the actual volume. Maybe the question may tell you to produce. They may give you volume. Listen carefully. I want to conclude this by saying something. Look up. This aspect can be confusing. There are two things involved in the alligation media: the proportion and the actual what? Volume. Proportion is not actual volume, it's just a ratio. Hope you know. It's not actual what? Volume. Now, if they want you to determine the actual volume, They will tell you the volume of the C you need to form. Let's assume now, I ask you, okay, produce 500 ml of what? Let's assume I ask you to do what? Produce 500 ml of what? C. Just like what volume of A and B can, what volume of A and B, okay, let me frame the question well. You can put B you can put B there. What volume, what will be the volume of, what volume of A, solution A? You know what, which one is A, right? A is what? 100 milligram per 5 ml, right? You can say, what volume of solution A and B do you need to combine, mix to produce 500 ml of what? C. It's simple. Yeah, EBAB is just ordinary mathematics. True of us. If the ratio, that means the ratio of A and B in this 500 ml should be what? 2 is to what? 1. Simple. This one is a simple mathematics. You can determine that, right? That means if you add the two of them, it will give you 500 ml. And inside that 500 ml, A must be twice B. That's the meaning. So it's simple. Using normal proportion. Now let's do that. So see, you have determined that. Let me use secondary school method, and so that those that don't understand that will learn it now. We know that VA. We've agreed, right, that ratio of V to what? VA to VB is what? 2 is to what? 1, right? Now that means V total is what? V total is what? 500 what? Mil. Okay, and right? Now, if the ratio of V to B is 2 is to 1, and the V total is what? 500 mil. We can find VA in 500 mil. We can also find VB in what? 500 mil. True of us. We simply do VA over what? VA. Okay, now let me break it down. I hope I'm not confusing someone, thinking that I'm trying to explain something. I hope so. If I'm confusing, let me know. Don't keep quiet. Can I clean here? Sorry. Good. All right. Now, the total V is what? The total volume is what? 500 mil. Then the total proportion for two of them is what? Is what? 3. Good. The total proportion is what? 3. Total volume is what? 500 mil. Total proportion is what? 3. Now, if you want to find volume of A, use the ratio of A divided by the total ratio or total proportion times what? 500 what? Mil. You get the answer. Are we together? So volume of A is now equal to what? Proportion of A in this mixture is what? 2, right? 2 over what? Total is what? Times what? What's the answer? 3 what? 33 point what? Good. Let me do that. 33.33 what? Mil. This is volume of A. Now, volume of B, remember the proportion of B is there is what? 1. 1 over total proportion is what? 3 times what? What's the answer? 166 point what? 6 what? 7, right? Mil. Add these two things. Add 333.33 plus 166.67. What's the answer? They must give you 500 mil. It's a must. 500 mil. Now, next thing you test is this. Test whether this is twice of this one. Multiply this by 2. Multiply the 160.67 by 2. Then divide this by 2. It should give you this. So now the volume. So if you now want to prepare this C, now what you need to do is just get 3.33 ml of what? A. Get 166.67 ml of B. Mix them together. You will get 500 ml of C, which has concentration of what? 75 milligram per 5 ml, which we change to percentage and got what? 1.5 gram percent weight in what? Volume. Simple. This is alligation what? Alternates. This is alligation what? Alternates. So these things are important. This is our manipulations you can do where you are working if the need arises. You know, which sorry to say so, but it is what it is. Which some people, some other person that didn't pass through this system may not be able to do what? Do. Yeah. Where?
VAVB.
1 over 0.5 is what? You mean that ratio? VA over VB?
Yes. After using the formula.
Okay, instead of 2 over 1.
Yes.
This is just notation. It's something. It's just notation. Okay. It also means 0.5 is what? Half. It also means that VB is half of what? VA. Is it not? VA over VB is 1 over half. 0.5 is half, right? Mean that VB is half of what? VA. If you remove that 0.5 mil, 0.5 decimal fraction, everything will become 2 over what? 1. VA is twice VA. What I did there, I just removed that fraction. Put it in whole number, simple. 1 over half is 2 over 1. So the ratio is, remember, it's better to leave ratio in whole numbers. It's not true. So it's 2 is to what? 1. Which means that VA is twice VB. While VB is half of what? V. Is it clear now? So that's what we did here. So with the volume now, I have fixed the volume now. With that, we're able to arrive at this place. So this is how to use what? Alligation what? Alternates. No, I just fixed the volume for you. I just say let's assume. Remember I told you that the question stopped at proportion. Get the proportion which we got, which is 2 is to what? 1. That is, you combine 2 of these